So additionally, once you figure out you're limiting an excess reactant, you can go a little bit further with excess reactants. So given this problem, if you have 16.2 grams of zinc and 23.5 grams of hydrochloric acid, how much of your excess reactant would you have left over in grams? So this is an additional problem that is building off of the previous problem that we had already done, just to remind you. Trying to listen to music, I guess. So we had figured out that our limiting reactant was zinc, and that we made 0.248 moles of zinc chloride. That also means by proxy that hydrochloric acid is our excess reactant. So we were going to have some leftover of that. So what this question is asking us is, well, how much is left over? So your limiting reactant limits how much you produce. We've got that. But it also simultaneously decides how much of your excess reactant you're going to use up, because once you completely run out of limiting reactant, the reaction's over. Nothing else is getting used up from either end of things. So what we can do here is we can take our limiting reactant, which we figured out was zinc, we can convert that to our excess reactant and figure out how much of that is actually going to get used up. Because we know not all of it's going to get used up. There will be some left over. So we can actually figure out how much would be. So we've got our 16.2 grams of zinc. Put that over 1. Convert our grams of zinc to moles of zinc using our molar mass, which is 65.37 grams of zinc and 1 mole of zinc. Then we're going to go ahead and do our mole ratio. So moles of zinc, and now I'm going to go to moles of hydrochloric acid. Why? Because we figured out that hydrochloric acid was our excess reactant. And I want to figure out how much of my excess reactant is left over, because I know not all of it's going to get used up. I am going to convert that to grams, though, using the molar mass one more time, because my initial value of my excess reactant is in grams. So I want to keep everything in grams. So now that I've got this set up, my ratio here is a 1 to 2. So for every 1 zinc, 2 hydrochloric acids are used up. And the molar mass of hydrochloric acid is 36.46, adding up H and Cl together. So let's go ahead and solve for this. So 16.2 divided by 65.37 times 2 times 36.46. I'm getting to, and I will need 3 sig figs, 18.1 grams of HCl. So let's just take a second and talk about what we just figured out. So all 16.2 grams of zinc are getting used up. That's limiting reactant. So if all 16.2 grams of zinc are getting used up, 18.1 grams of hydrochloric acid are going to be needed to react with it. Well, I had 23.5 grams. So this number we just calculated is how much gets used up. Well, how much did I have to start off with? It looks like 23.5 grams is what I had. So that's how much I had. That's how much I used. My question is how much is left over? Well, subtract them. So I'm not doing that in my head. So 23.5 minus 18.1 is going to be 5.4. Remember, the rule for adding and subtracting is to line it up, which I did. So this is 5.4 grams of hydrochloric acid left over, because it's the excess. It's not going to get all used up. So that is how much is going to be left over, because that's how much gets used, and that's how much I had. So basically, once you figure out the limiting reactant, you can use that value to figure out a bunch of different stuff. Essentially, because that decides everything in the reaction, because once it runs out, the reaction stops completely. There's one more final thing that we can use all this information for, and it's to calculate percent yield and percent error. So ideally, we use stoichiometry in lab. We're trying to make something, and we're trying to make a specific amount of that something, and we use the stoichiometry to help us figure out how to make that specific amount. So let's say we did this reaction in real life, okay, using the same numbers that we've been using. 16.2 grams of zinc, 23.5 grams of hydrochloric acid, mix them together. We know the zinc gets all used up, so that's gone. We know there's some acid left over, and we make zinc chloride and we make hydrogen gas. So let's say we actually did this in real life. And so I actually produced 38.7 grams of zinc chloride. All right, I filtered it, I measured it, that's the amount that I got. Percent yield and percent error is a way for us to measure as scientists like how good of a job we did. So if you want to just look at these basic equations here, percent yield is your experimental minus your expected. Experimental is what you actually got in the experiment, and the expected is your calculated value, sometimes referred to as your theoretical value. That's like what the math told you should make. So one number is what the math said, one number is what you actually made. So math, let's say you actually made 1 gram and you should have made 1 gram according to the math. 1 divided by 1 is 1 times 100 is 100. So 100% yield is what we're always shooting for. We want to make what we expected to make. Well, in science, it doesn't always work that way. Percent error is a very similar calculation. It lets you know how far you deviate off of 100. So if you have like a 2% error, you were 2% off the margin. If you had like 50% error, you were 50% off of what you should have gotten. So I'm not going to flip back for the sake of time, but on the previous video, we had figured out we should have made 33.8 grams. That's what the math told us. That's how many grams of zinc chloride we should have made according to the math. So now what I'm telling you is we actually made 38.7. So let's figure out what the percent yield is. Again, our equation here is actual over expected. So if I actually made 38.7 and I should have made 33.8, and you're ultimately going to times this value by 100. So 38.7 divided by 33.8 times that by 100, I get 3 sig figs. My final answer is coming out to be 114%. So remember, 100% is the goal. So 114%? Okay, so we made more than we should have. This gives us an idea as scientists of what could have gone wrong and where it went wrong. Because here's the thing, you didn't just magically make more zinc chloride. Like, I can't just like magically make more grilled cheese if I only had 4 pieces of bread. There's another error that's going on here. Maybe there's some excess reactant laying around that's causing it to weigh more. Maybe it's wet. Maybe there's something else in there. There's a slew of things that could have happened. So this kind of clues you into what could have happened and how much that error did happen. So now let's go ahead and do the percent error. So this is expected minus experimental. So I expected 33.8. I got, what was it? Yeah, 38.7. And this ABS is standing for absolute value. So you just want to take the absolute value of this. You basically just don't want it to be a negative number because we're not going to have a negative percentage. And you're dividing that by what you expected to get, which again was our 33.8. So 33.8 minus 38.7. In this case, I am getting a negative number. So just take the absolute value of it, make it not negative. So that is 4.9. And then divide that by what you should have gotten again. So divide that by 33.8. Notice now that it's 2 sig figs because of the subtraction rule. Times that by 100, and you're getting 14%. Here's the thing. The percent error and the percent yield should match up because your percent error is how far off the margin you are. So you're 14% off. Well, I got 114% yield. So those should always work in tandem with one another. The percent error doesn't tell you if you were too high up or too far down. That's what the percent yield tells you, which is nice. Yeah, that's our idea there. So this is just a little bit in addition to the stoichiometry we previously did. What I have below is a practice problem. I highly encourage you to pause the video right now and try this and tune back in when you are ready. All right. So if you were able to get through this and if our answers are looking great, you were sitting in an awesome spot. I wanted to just note that I did the limiting reactant part slightly differently just to give you another way to solve this. In all the other examples I was doing, I was just solving to moles. But if you notice here, I actually did one more step and I solved to grams of the product. Because if you look ahead, this asks for how many grams of copper are formed. So since I went all the way to grams in this step, once I figured out which is my limiting reactant, which one made less, which was the CuCl2, then I literally have my answer to the next problem. So I just did like all the work at once just to save myself some time. This one was a lot of work. My apologies. I probably just should have said grams and it would have been less work, but this is okay. Basically, convert your limiting to your excess. That's how much you used. And then you subtract that from what you had to get what's left over. Percent yield, take what you what you actually made, excuse me. So you actually made 1.01 grams in the experiment. The math says you should have made 2.78. So what you actually made divided by what you theoretically should have made. So 36.3%. That's not great. So if like you actually did this in real life, that's not an awesome percent yield. And clearly you made less than what you should have made. Maybe you dropped something, or maybe the reaction didn't fully take place, or there was some left in the beaker when you poured it out. There's a lot of things that could have happened there, but that lets you know that that wasn't the best thing. All right, go ahead and do some more additional practice, and if you need anything, please do not hesitate to reach out.